Ta-da! Ooh, so shiny. Alright, so maybe it's not magic, but the inverter is back together, and I've tested it well enough to know that it works properly, but I don't know how well it works, and I haven't stress tested it yet, so things like severe overloads and continuous high current draws, I need to test and make sure that it works properly before I decide to keep it or sell it or whatever I do with it. But I want to see how this PowerBright 2200 watt Pure Sine Inverter works. So the first thing to do is turn it on. We have 117 volts out. Over here I have a meter hooked up to measure the current, and you can see that at no load it draws, it jumps around a bit like they often do, but 700 milliamps or so, 0.7 amps, somewhere in there. I have it connected up to these two deep cycle batteries, Autocraft deep cycle batteries. I really like these, they're pretty nice batteries. And I have that connected up through these 2-gauge cables. I had cheaper, I think it was 4-gauge cables, I'm not exactly sure, they're not labeled, but connected up before and those weren't adequate. But these work quite well, so I'm going to use those. And I also have this battery charger, 45 amp charger on my batteries, just to make sure that everything runs smoothly. So let's turn on a load here. I just turned this electric heater on high. You can see that the voltage sagged just a little bit, not bad. And it ends up being about 1300 watts on that heater. And the input battery voltage is 12 volts, so my batteries are doing just fine. And 126 amps. So the general rule here is that you get 10 amps per 100 watts, so I'm right on that. That's no problem. Let's increase the load here a little bit and make sure that this inverter works properly. I'm just going to start screwing in light bulbs. This meter will probably complain because it's not rated to run more than 1500 watts or so, but I'm going to ignore it. I'm not going to run it too long, so it's probably not going to start on fire. Except my circuit breaker and my power strip tripped. So apparently that's not a good idea. Different strategy. I'm unscrewing some of these light bulbs. I can take this, plug it in straight into the inverter, turn my power strip back on. Alright, so we have that going now, and I'm going to turn in all of these light bulbs in my light bar. So we still have 115 volts coming out of it. We have 1300 watts into the heater. Now I'm just going to trade these so that I can see how many watts are coming out of each. There's 1300 watts in the heater. Plug my heater into the inverter now, and the lights into this guy, and we get 1300 watts plus about 800 watts. And what do you know, that's 2200 watts. Very, very close to it anyway. So this inverter is fully loaded. It's drawing 220 amps from the batteries, and the batteries are supplying about 11.5 volts. Now I want to check my connections quick just to make sure that there's nothing going wrong with these. I don't want something to overheat. Alright, so that all seems to be fine. The inverter is fully loaded, 2200 watts, and it's working very, very well. I'm extremely impressed. 115 volts out at 2200 watts. That's pretty dang impressive, to tell you the truth. This is a Pure Sine inverter. 11.4 volts, or 11.4 volts in, drawing 220 amps out of the batteries, and the fans just turned on. I'm not sure exactly what triggers the fans to turn on and off. They appear to be temperature controlled somehow, even though there's no temperature sensors connected to the heat sinks inside, but it seems to work pretty well. I'm just going to let it run this way for a while and do a long-term stress test on it at 2200 watts, and we'll see if this inverter survives. When I got the inverter, it was broken. It had a fried diode inside, as well as lots of other problems. So I fixed all of those, and I want to make sure that it works, so I'm doing the stress test. I'm going to let this run for a while. These batteries should last for quite some time. This inverter will complain once it gets down to 11 volts, but I'm going to let this go for 15-20 minutes or so, make sure that it can do a long-term high current draw without any issues. And after that, I'm going to move on to some other tests. Well, this inverter has been running a pretty heavy load for 15-20 minutes, somewhere in there. This heater and my entire light bar over here, and around 2,000 watts or so for most of this duration. I've changed the load somewhat, varied it up and down to get some sort of efficiency curve out of it. And the efficiency of this inverter really is pretty good. I opened it up earlier and mentioned that it didn't look like they improved much inside of this compared to the 1500 watt one. But the efficiency is 2 or 3 ticks higher, 2 or 3% higher. And that makes the efficiency pretty darn good, really. 2 or 3% doesn't sound like a lot, but 2 or 3% ends up being 20% more efficient, something like that. And that puts this inverter up in a pretty exclusive group. It's pretty good. It's better than the Samlex 2000 watt inverters are, and it's not as good as the 3000 watt ones are. But the no current draw on this one is pretty low, so that makes up for some of it too. Now, I don't know if some of that efficiency improvement is because I replaced all of the input stage here, some of the output, and some other components. My replacement components may have been better quality than the ones that they put in here initially. I don't really know. They could have also been lesser quality. You would really have to be the designer of this particular product to know, but it's possible that that changed the efficiency somewhat. However, I'm pretty impressed with this so far. So let's see what kind of voltage regulation this thing has. Now, there's a few ways to do this, but I'm just going to do this the poor man's way. I have this light bar running, and I have this electric heater, so I'm turning the heater off. The heater's off right now. And I'm just going to keep these light bulbs slightly out of frame and turn this heater on high. That's 1500 watts, which puts us up near its limit of 2200 watts. And let's see if these light bulbs dim at all. I can turn the heater however I want, high, low, off, whatever, and the light bulbs stay completely constant. So just like the 1500 watt version of this inverter, I'm quite impressed with the output quality of this. Its voltage regulation is very, very good. The chirping that you heard is partially because of my input cabling here. However, it is also partially because of the internal construction of this inverter. It appears that the transformers in here, there were 3 transformers, which seemed a little bit inadequate to me, and apparently it is, because the input voltage only goes down to 11.5 volts or so, and the fans just shut off, interestingly. I'm sure they'll turn on again soon. But the input voltage would droop down to about 11.5 volts. That should be plenty adequate to power this, yet it still complained of low voltage. But the way that these things sense low voltage is actually not how you might think. They don't actually care what the voltage is coming in. They don't look at that. They don't care whatsoever. That's my meter beeping. I just turned it off. The input voltage is irrelevant. These inverters don't care. What they care about is once it goes through the boost stage, through these transformers that are inside, through the rectifier diodes into the bridge and into those caps that are right below here. Once it goes through all of those steps, all it cares about is the voltage of these capacitors. Now, when components get warm, things change. That rectifier bridge that's over here, actually as it gets warmer, it gets more efficient. That's how diodes work. So that part doesn't get stressed at all. The input FETs, however, the warmer they get, the higher resistance they are, since they are resistance devices and they have a positive temperature coefficient. So they get higher resistance as they warm up, and that higher resistance means a greater voltage droop. They go into the transformers, which have a higher resistance as they get warmer, and the fans just turned on again. So these also have a greater voltage droop. So when you add the FETs and the transformers, where almost all of your losses are, and then your diodes over here, which You don't get a whole lot of losses in those. It's 20 watts or so, not a whole lot, considering you lose a few hundred watts in these other devices. What you end up with is when the internal components get warm, they end up with a higher loss and you require a higher voltage before the inverter complains. Now, I don't really want to knock this inverter for that. It is a mid-range inverter. It's not a very high-priced one. The Samlex ones, for example, the 2,000 to 3,000 watt models, those are extremely good. As I've said before, I'm highly impressed with those. And those don't have this issue, but in this price range, I'm not entirely surprised that they do have that issue. So I'm not going to knock it too much for that. Overall, this is a pretty nice inverter, I must say. Now, I do have some more things to test, so I'm going to hold judgment until then. But the next thing I want to test on this is the surge capability. Now, judging from this here test that I just did, it's probably not too bad, but the 1500 watt inverter had basically zero surge capability. So let's give that a try and see what this one has. I almost forgot to mention the efficiency of this thing. The 1500 watt model was around 85% efficient, I believe, if I remember correctly. You can watch that video to get the exact numbers. But I tested this one and it was a few ticks higher. About 87% under full load. I believe this meter actually reads a little bit high, so it might be a little bit higher than 87, but in any case, this inverter is pretty good in terms of efficiency. The highest efficiency I've seen from any inverter, given my test setup here, is just over 90%, 92% in fact. That was my MotoMaster 3000 watt modified sine wave inverter. The Samlex 3000 watt inverter was basically equivalent in efficiency. However, its no load power draw was 2 amps. Again, I'm highly impressed with that one. It's very, very nice for multiple reasons. But this one here almost matches that one, so I'm surprised and impressed with it. Its voltage output regulation is pretty good too. The Samlex inverter has an extremely high surge capability. It can drive inductive capacitive loads extremely well. This one probably can't do that, but I have here in my hand an extension cord. This thing snakes down into my basement, and I have it connected up to a old 1980s dehumidifier, which I've used many times. See my previous videos for an explanation of why I'm using that unit, but it has a approximately 3500 watt startup surge in order to power that. It's a reciprocating compressor pump in that dehumidifier, so it takes a lot of power to start. Lots of inverters have trouble with it. I'm happy to say that the 1500 watt version of this PowerBright inverter starts it up just fine. This is a 2200 watt model, so I also anticipate that this one will start it up just fine. It certainly should. The 1500 watt model, as I demonstrated in a previous video, it does not have any surge capability whatsoever. It instead does a soft start, sort of startup surge capability method, and I don't particularly like that. I would rather it have a real surge like the Tiger Claw inverter did. However, soft start is a valid technique. I don't really have a problem with it, except that, for example, let's say you have this inverter running some I don't know, a load of some sort, lights or something, and your refrigerator decides to start up. Okay, no problem. The soft start mechanism takes over. The voltage droops down to 90 volts, and your refrigerator starts up, and the voltage comes back up to 115 volts or whatever it might be, and everything's happy. Sure, your lights dim during that time, and your computer power supply and whatever else happened to be running off of it also had to work harder briefly, but everything was fine. So the refrigerator runs for a while, it decides to shut off, and you go over to your refrigerator, open up the door, pull something out, shut it, and your refrigerator sees that the temperature increased. So it says, well, I've got to start up again. And the compressor tries to start up. Well, in this case, it's short cycling. And in a short cycle configuration, your compressor in your refrigerator is not able to start up nearly as well. It requires a lot more torque to start up into a reciprocating compressor load where there are pressure differentials still existing in the system. And if you had a good inverter that had a high startup surge capability, it would be able to overcome that and your refrigerator would start up. However, if you have an inverter like that 1500 watt PowerBright that has a soft start technique instead of a real startup surge, then you end up having to droop down to 80 volts or whatever it might be in a locked rotor condition, like your refrigerator is when there's a pressure differential, and your refrigerator might not be able to start up. After half a second or so, an inverter like this shuts down and says, whoop, I can't start it, that's too much load, and it shuts down, and you end up having to power cycle your inverter. It's kind of annoying, it's not really the best system. I like the way Sanlex does it better. It's a higher priced inverter, and it costs a lot more to do it that way, but that particular inverter really does surge up to 6,000 watts. That's enough to power your compressor in your refrigerator in a locked rotor condition for the 10 seconds or so it takes for that compressor to overheat, the internal protection to trip, and after a minute or so it will reset and your refrigerator will start up. That's how it's designed to operate. When it's plugged into the wall, if it gets into a short cycling situation, the compressor is not able to start that pump, it overheats, the thermal protection trips, and after the thermal protection resets, then the compressor tries again and it starts it up. That's how it's intended to work. It does not work properly off of something like this that is a soft start technique. But anyway, I don't want to spend too much time here talking about that. So, over here I have my, my clamp meter set to peak. So it's going to record the amperage peak draw. In my hand here I have a cord that's connected to my dehumidifier. And I'm just going to plug this thing in and make sure that this inverter can start my dehumidifier. And of course it starts it up just fine. I expected that because the 1500 watt version started it up just fine. You can see that the dehumidifier takes a pretty hefty 600 watts or so while it's running. It is a very old one, and a very large one. I think it's a 50 pint. Anyway, the startup surge was 220 amps. That's about 2,200 watts out, which isn't too much of a surprise. But let's check a locked rotor draw condition. I fully expect this inverter to not be able to start the compressor under that condition, because wall power can't even do that, and it will overload. So we're going to test two things here. Number one, we're going to test what the duration of overload this inverter can support. I suspect it'll be about 1/2 second. That would be pretty typical for an inverter like this, but we're going to check that and make sure that it is in that range. And secondly, I'm going to see what the maximum output capability of this inverter is. It is a 2200 watt inverter. It is advertised as 4,400 watt surge, but as always that's complete bunk, I betcha. So we're going to find out. I'll take this cord, unplug it, and I'm not going to let the pressure differentials in that dehumidifier equalize. I'm going to plug this in. It won't be able to start it. My inverter will overload, but we're going to see how many amps that this thing can actually draw from the battery. And there you have it, 234 amps. Now, it's not defective in that it wasn't able to start it. I fully expected that. However, that is a pretty sad showing, 234 amps. That means that this inverter has no surge capability whatsoever. It relies solely on its soft start technique. And I don't like seeing that, but in this price range, I can't knock it too much for that. It does seem to work pretty well. Okay, the pressure differentials in my dehumidifier have equalized by now, so this inverter should be able to start up my dehumidifier without any issue. And I just want to see how much voltage droop I really get out of this thing when it starts up a very heavy load. So to do that, I'm going to take my light bar that I have over here. I'm going to plug that in. I'll plug it into my meter over here, turn on my inverter, And I have 300 watts over here going off of it. Pretty small load considering this inverter's capabilities. And I'm going to take this plug, which goes to my dehumidifier, and plug that into the inverter. And let's see how much these lights dim. This will just be kind of a subjective test, but gives you a good idea of what would happen if a heavy load started up and you had some other appliances connected up to it. So they dimmed a little bit, not too badly, and you can see that the dehumidifier started up with no problem whatsoever. And it seems to run just fine. So one additional test here. Let's hook up my multimeter and see what kind of output waveform we get. I have that dehumidifier running off of the inverter and 300 watts of light bulbs. And you can see that the output waveform is a pretty nice clean sine wave. I don't have any complaints about that. This is not a true oscilloscope. I don't have a power analyzer on hand, so I can't really tell you how clean it is, but it's pretty clean based on what it looks here. So what I'm going to do next is turn on an electric heater to load this down a little bit more. It's only loaded to about 1 kilowatt right now, so I'm going to load it to about 2 kilowatts, and let's see if the waveform changes. I just put about 1,000 watts more onto it, so this inverter is outputting around 2,000 watts. And you can see that the waveform is still nice and clean. So, basically, I like this inverter, is the conclusion. And I am somewhat impressed with that conclusion. The 1500 watt one I was not entirely impressed with. And that's basically based on the resale price. The 2200 watt one only sells for about $100 more, and it's far more capable. So this one I'm actually okay with. The 1500 PowerBright Pure Sine inverter had 0 startup surge capability, and I didn't especially like that. However, this inverter has 0 startup surge capability, and I'm okay with that. And the reason that I'm okay with this one having 0 and not the other one is because this is a 2200 watt model. And a 1500 watt model, 1500 watts isn't very much for startup surge. It really doesn't cover many things at all. My refrigerator that takes 150 watts or so to run has a 1100 watt startup surge, so really 1500 watts isn't enough to do much of anything. 2200 watts on the other hand is much better than 1500, so I'm actually okay with this one. And the efficiency of this inverter is pretty good. The output quality of the waveform is pretty good. My only real complaints are the very poor construction quality of it. When I reassembled it, I actually had to take it out to the garage and blow out all of the metal filings and such with an air compressor. For example, the heat sinks inside, they don't really tap those properly, and when you thread the screws in, it just extrudes thin pieces of aluminum out of the heatsink, and it really is pretty sad, the construction quality of this inverter. And that's really my main complaint about it. Functionally, I really like this. It functions very well. It's just the construction quality that's so poor. But I'm looking at it here on my table, all fully assembled, and it seems pretty solid. It's a nice solid case. I don't have any complaints about how it's constructed that way. But after opening it up, I know that there's some issues inside. So would I recommend this? Well, I guess it depends on what you want. The efficiency is pretty decent, and the output quality is pretty good. It's just maybe not as good as it should be for what you're paying. And that's pretty typical of sine wave inverters. If you have a choice between the PowerBright and a Samlex or Go Power inverter, I would recommend you go with the Go Power Samlex inverter. However, I don't think this is a bad choice. In fact, I am seriously considering keeping this one and selling my Tiger Claw instead. And from my previous videos, you know how highly I regard the Tiger Claw inverter. This is a much higher dollar inverter, however, I got it for almost nothing, so I'm thinking of keeping this one instead. Regardless, this PowerBright 2200 watt Pure Sine Inverter. I rather like it. I'm surprising myself in saying that I would actually recommend this inverter. I would not recommend this for a on-vehicle application because it is not vibration resistant. However, for a stationary installation, I think that this would be a good choice. So, there you have it, the PowerBright 2200 watt Pure Sine Inverter. This one is repaired. It functions perfectly. I have stress tested it and tested its performance, its efficiency, and everything else. And that's the end of my video. So, thank you for watching.